All right, let's get into it. Have you ever used an app and just felt like it gets you, like it knows what you want before you do? Well, today we're pulling back the curtain on the AI's secret memory that makes all of that possible. And trust me, it's a technology that is changing absolutely everything.
Think about it. You open up Spotify, and it suggests a song that just perfectly hits the mood you're in. Or Netflix recommends a movie you didn't even know you wanted to watch. It's not just matching keywords, right? It's understanding your vibe. So, how on earth does it do that?
Well, it all boils down to this: the difference between searching for words and searching for meaning. You see, a traditional keyword search is super literal. If you type in dealing with COVID anxiety, it's looking for those exact words. It would probably completely miss an amazing podcast called How to Cope with the Pandemic, even though that's exactly what you're looking for. To get better answers, we have to go beyond just words and get to the intention behind them.
Now, this ability to search by meaning, it can feel like some kind of magic, but it's not. It's all powered by a really special kind of database that has become the secret weapon for pretty much all modern AI. So let's pop the hood and see how this thing actually works.
We're calling this whole concept the AI secret memory. Because really, that's the best way to think about it. It's a system that doesn't just store words or files, it stores concepts, ideas, and the relationships between them.
So the very first piece of this puzzle is something called a vector embedding. This process is just fascinating. An AI model takes a piece of data, could be text, an image, a clip of a song, anything, and it translates it into a really long list of numbers. You can think of this list of numbers, this vector, as a kind of digital fingerprint. It captures the true essence, the meaning, the context of that original data, all in a language that machines can finally work with.
And where do we put all these millions of digital fingerprints? Well, they go into a vector store, which is sometimes called a vector database. Its entire job, its whole purpose, is to store these massive lists of numbers and, this is the crucial part, to search through them at lightning speed to find the ones that are most similar.
Okay, so with that in mind, let's look at how this builds a totally new kind of library. Forget the Dewey Decimal System. This is a library organized purely by meaning.
You know, this is probably the best analogy for it. A traditional database, it's like a dictionary. It's organized alphabetically, right? You look up an exact word and you get its exact definition. It finds exactly what you say. But a vector database, that's more like a thesaurus. You look up one word and it doesn't just give you a definition. It gives you a whole cloud of related ideas, synonyms, and concepts. It's built from the ground up to find what you really mean.
So, if everything is just a bunch of numbers in a database, how does it possibly know which ones are similar? This is where we get into a little bit of math, but honestly, the core idea is beautifully simple.
It's all about distance. The system measures similarity by literally measuring the mathematical distance between two of those number lists, two vectors. Just imagine plotting two dots on a piece of graph paper. The closer they are, the more related they are. It's the exact same idea here, except it's not happening in 2 dimensions, but in hundreds, sometimes thousands of dimensions.
And that's the golden rule, right there. The closer two vectors are in that crazy multi-dimensional space, the closer their meanings are in the real world. Now, there are different ways to measure this, like Euclidean distance or cosine similarity, but they all follow that same fundamental principle. Proximity equals similarity. Okay, so this all sounds amazing in theory, but what happens when your database doesn't have a few thousand vectors, but millions, or even billions of them? You run into a very, very big problem.
Right, exactly. If your app had to compare your search query to every single one of those billions of vectors, one by one, well, it would take forever. It would be totally useless for any real-time application. So how do they get around this?
The solution is this brilliant, brilliant trade-off. Instead of trying to find the single, absolute 100% perfect match, which is super slow, the system uses these clever algorithms to find a good enough match or a bunch of really close matches incredibly fast. This whole idea is called approximate nearest neighbor search.
And a great example of this is an algorithm with a wild name, HNSW, which stands for Hierarchical Navigable Small World. You don't need to remember that, but what it does is amazing. Instead of checking every point, it creates this kind of network, like a spider's web. It starts your search at a random point, then it intelligently hops to a closer neighbor and then to a closer one, getting progressively closer to your query with each jump. It just stops when it finds a match that's good enough. It's an incredible shortcut that makes the whole process ridiculously fast.
So,
Now we have a way to find a group of similar results really, really quickly. But here's the thing. Similar isn't always the same thing as best or the most relevant. To get truly great results, you sometimes need one more step to really polish everything up.
And that final step is called re-ranking. So after the vector store zips back with, say, the top 100 most similar results, a second, often more powerful model takes a closer look. Its only job is to reorder that list. It pushes the most genuinely relevant results to the very top, and maybe it gets rid of stuff that's kind of repetitive.
But of course, there's a catch. Re-ranking has huge benefits. You get much better accuracy, and it can even help stop AI chatbots from making stuff up, from hallucinating. The downside? It's another step. That means it adds a little bit of time and costs more in computing power. So you're always making a choice, a trade-off between getting perfect results and getting fast results.
So why does any of this matter to you? Because this technology, these vector stores, they are the quiet engine behind so much of the internet you use every single day. They are what power those recommendation engines on Spotify and Netflix. They're what allow you to type a full, natural question into a search bar. They are an absolutely critical piece for advanced chatbots that need to pull real-time information from huge documents. And, maybe coolest of all, they let you do things like search for an image using only a text description, totally bridging the gap between different kinds of data.
And that really brings us to the big picture. This shift from searching for literal words to searching for abstract meaning isn't just a small upgrade. It's a fundamental change in how we interact with information. It's what makes AI feel more intuitive, more helpful, and frankly, a little more human. So the real question we should be asking ourselves is, what's next? Now that we can organize and search the world's information by what it truly means, what incredible new problems are we going to solve?